let's do a little more practice with this unfoiling method. So I put up 5 practice problems here so we can sort of delve into and get a little more practice unfoiling. And then I have a couple problems over here to show you what it would look like if there happens to be a GCF in the problem. Because remember, you always want to be looking for a common factor when you approach a problem. So in these situations, there's no common factor. There's no x at the end of any term. This one does look possible, right? It looks more possible to have a GCF, but notice I've got y's, y, no y, x's, x, no x. They don't have any variables in common, and still the coefficient of 1 out here doesn't give us a significant numerical common factor. So there's no GCFs in any of these first 3, so we can start off. All right, unfoiling. All of them are going to start off the same way because we know our first 2 pieces have to be x. All right, now I'll just walk through and practice these on your own if you want to pause the video and try to see if you can get them right before I fill in the blanks here. All right, we want to find factors of 8, so numbers that multiply to 8 that would add up to 7. So we have 4 times 2 and 8 times 1. And here only one pair works. 8 and 1. So 8 and 1. And what 2 signs would I need to make a positive 7 show up in the middle? Well, we need positive 8 and negative 1. All right, 8 minus 1 is 7. 8 times negative 1 is negative 8. And got this figured out. Right, sometimes this type of problem throws people off because they don't see a coefficient in the middle that they want to add up to, but we do know that that is representative of a 1. So don't let that throw you off. We're still looking for factors of 30. Let's say 6 and 5, 10 and 3, 15 and 2, 30 and 1. You don't have to write them all down if you see the one that works right at the beginning. So we could have stopped right at the beginning with 6 and 5. 6 and 5 have a difference of 1, so that's good news. All right, 6 times 5 is 30. And to end up with a positive 1 in the middle, we would need positive 6 and negative 5. 6 minus 5 is 1. 6 times negative 5 is negative 30. Just a quick double check to make sure we factored that correctly. Another situation that sometimes throws people off is when more variables are involved, but don't let those variables affect how you're going to approach this problem. I know x squared has to be x times x, so I'm going to start there. All right. And still follow the same pattern. Look for 2 numbers that multiply to 32. They can somehow add up to 12. So we have 32 times 1, 16 times 2. Times 4. I think those are our only options. All right, 8 and 4 is a good pair. All right, what 2 signs would I need to add up to negative 12? And we talked about it last time. Again, notice this positive 32 is also helpful as well, because I need to multiply to get positive 32. The only way for me to do that is if both of these are negative. Negative times negative is positive, and negative plus negative is more negative. So for both reasons, this should work out. And this would be completely the right answer if I didn't have any y's in the problem. You factored it correctly, and you've done the difficult part. We just have to account for this y in here, and these 2 y's at the end. Right, well, the good news is we don't have to worry about this y if we take care of these guys. Right? We saw that x times x is x squared. Right? I would also need 8 times 4 to get me 32y squared, because this whole term comes from these last 2 pieces being multiplied together. In order to get y squared, same deal. I need a y and a y. All right, and that's it. You don't need to affect anything else to make this x, y happen. It actually happens naturally when you FOIL this problem out. All right, I'll just show you really quickly. We'd have x squared, that's good. distribute this, x times negative 4y, that'll give us negative 4xy. So see, we don't have to add an extra x anywhere. This x is right here. It's getting distributed. It's part of this term. And we distribute here, it's negative 8x and y. So again, we have an xy term that shows up. And lastly, importantly, we get this last term because negative 8y times negative 4y would be positive 32y squared. And we can see these middle two terms would combine to get back to here. Okay, so this is actually the correct answer. We don't have to add any more variables, so don't let the extra the extra y's or y squareds throw you off. Just tag them in here at the end, and that's good enough. All right, so let's look at a little more difficult problem, one with a GCF in it. All right, most of the time, and specifically in the future in Chapter 7, I'm not going to tell you that a GCF exists. I might remind you, hey, look for GCFs. But I'm not going to tell you specifically there's a common factor in each problem. It's going to be your job to look at this and say, oh, I see something in common. Oh, I see something in common. But for now, in these problems and on Math Lab and this homework, it tells you, make sure to factor out the GCF first. Okay, so in this situation, there is a common factor between all three terms. There's no x back here, but they do have a common factor of 2. So remember, when you have a common factor, you just write down what that common factor is, and you open up one set of parentheses, and you just write down what would be left over. All right, these problems have to be done in 2 steps. It's a GCF first, and we say, okay, if I divided all these terms by 2, then this would just be 1x squared. 6 divided by 2 would be 3x, and 20 divided by 2 would be 10. All right, so that's the GCF portion of this problem, but once you remove the GCF, sometimes that polynomial that's left over, right, looks a whole lot like the name of this section. Right, x squared plus bx plus c. We still have it here. So that would, then you might look at this portion right here and say, well, this piece, I know how to handle that. That can be unfoiled. Right, for one reason or another, a common mistake is just to say, well, I factored out that greatest common factor of 2, I don't need it anymore. And people forget to keep writing the 2. Right, the 2 belongs, we're just rewriting this expression as in factored form. We're saying, what are all the things that would need to be multiplied together, right, to get this back at the beginning? So the 2 is part of it, so I need to write the 2 here. We're just breaking this apart further. So this would be x and x. Okay, 2 numbers that multiply to 10 that can add up to 3. Not many options. Hopefully you came up with 5 and 2. And if they wanted to add up to a positive 3, we would need a positive 5 and then negative 2. So all 3 of these things, when multiplied together, would get us back to our original problem. So the 2 is necessary to keep. We're just breaking it into smaller pieces. Same goes for this last example here. Right? They do have something in common, and not just a number this time. Although they're all divisible by 3, right? They also have all x's in them. So remember, use the smallest power. So there's a common factor of 3x in this problem. Right? If we divide every term by 3x, or remove it from every problem, right, we need 3x times x squared. 3x times x squared would be 3x cubed. 3x times x, 3x times x would be 3x squared. And 3x times 2, 3x times 2 would be 6x. Right, so this GCF was removed from the problem, but it's still sticking around, right? You cannot get rid of it. You're just saying, this is one of the pieces that I need to multiply to get back to the original polynomial. So it's still here. We're just going to take this polynomial and say, well, I know how to break that down further. This can be unfoiled. Okay, 2 numbers that multiply to 2 that add up to a negative 1 in the middle. Well, that has to be 2 times 1. 2 times 1 is the only option for 2. And if these 2 have to add up to negative 1 or group together to get negative 1, I would need negative 2 and positive 1. So all 3 of these pieces have it broken apart. All right, so there's more practice, right, with our basic polynomial factoring with just an x squared in front. Next section, we're going to make it a little more difficult and put a coefficient in the front and make it so there's no greatest common factor. It makes it a little more difficult of a task to factor, but we're still going to be unfoiling. Same kind of process, same kind of thought process, maybe just a little